Good day everyone. So let us now continue our discussion regarding the dimensionless number. And now let us discuss the Grasov number or GR. Okay. So Grasov number represents the ratio of the buoyancy force. It represents the ratio of buoyancy force to viscous forces. Okay. So what can you notice about this Grasov number or GR? Right? We have also the ratio of the buoyancy force and the viscous forces. And if we recall the RE or our Reynolds number, it is actually the ratio of what? The inertia forces and to viscous forces as well. Okay, so if you notice, the Reynolds number is the one responsible or applicable to forced convection, right? And if you remember also, we tackled this application last time by having the tables of these dimensionless numbers. Okay, so the Reynolds number is the one responsible for, is the one that's being applied for the forced convection, having the ratio between the inertia forces to the viscous. Okay, while the Grasov number is the ratio between the buoyancy forces and the viscous forces. So the role played by this Reynolds number in forced convection is actually the role of the Grasov number in natural convection. Okay, that's why if you can also remember that we say when we have a natural convection, the flow is made by the buoyancy forces due to the temperature difference, right? Okay, so that's the relationship between the two dimensionless number. The role of the Reynolds number in forced convection is actually played by the Grasov number in natural convection. So as such, the Grasov number provides the main criterion in determining whether the fluid is laminar or turbulent in natural convection. Okay, did you see the similarities? The Reynolds number can determine the flow condition, whether laminar to turbulent in forced convection. And while if we have a natural convection, we will gonna use the Grasov number to determine whether the fluid flow is laminar or turbulent, okay, using this Grasov number. Okay, so moving on, the Grasov number is equal to G beta Ts minus T infinity LC to the cube all over V squared, right? So we have also presented this last time in the table, okay? We're in the G is your our gravity, the acceleration to gravity. Then our beta is the coefficient of volume expansion. Coefficient of volume expansion. that is actually 1 over k, or beta is equal to 1 over T for ideal gas. Okay, and of course, our Ts and T infinity is the temperature of the surface and the temperature of the fluid. Decreasing. Okay, what else? Again, our LC is the characteristic length of the geometry. Characteristic length of the geometry, usually in terms of the unit meter. And our V is of course our kinematic viscosity. Okay, so that's all for the Grasov number. Okay, simply once again, the role of the Reynolds number in first convection is played by the Grasov number in natural or free convection. Okay, so they are both um, responsible to determine the flow, whether it is laminar to turbulent flow. Okay, moving on, we have oops, our I think this is the last dimensionless number that I am gonna discuss. So we have the Rayleigh number, or RA. Okay, so this number is only the product of the Grasov number and the Prandtl number. So we can say that RA is the product of GR and PR, right? Hence, the Rayleigh number itself may be viewed as, if we're gonna expand this, we can view the Rayleigh number as the ratio of the buoyancy forces and the thermal and momentum diffusivities. Okay, so using this relationship, the product of the Grasov and the Prandtl number, we can say that the RA, or the Rayleigh number, is the ratio of buoyancy forces and thermal and momentum diffusivities. Okay, that's it. This is simply the Rayleigh number. And if we gonna relate this to Nusselt number, did you remember the Nusselt number? So Nu is equal to H characteristic length all over K. And if we gonna relate this Nusselt number to Rayleigh number, then we can have a CRA raised to N, wherein our C here is the value of the constant C. This is actually a constant. And also this N here is also a constant, wherein their value depend on the geometry of the surface and the flow regime. Okay. Okay. So the value of n, this n, usually is 1/4 for laminar flow, while 1/3 for turbulent flow. Okay. So, and the value of constant c is normally less than 1. Usually, usually or normally. Okay. So that's it. The relationship of the Rayleigh number to the Nusselt number, where a Nusselt number is equal to HLC all over K. You can equate this if we're gonna determine the relationship, is we have C, R, A, N, wherein C and N are constants, which depends on the geometry of the surface and flow regime. Okay. So that's all for the different dimensionless number, and on the next video we will gonna tackle another topic, which is regarding the concept of the what we call the boundary layer. Okay, so see you on our next video.